to Choose Your Own Adventure, the dignified pursuit of a developer platform. Meet Hero. Hero is application source code on a developer's laptop. Hero longs to be a real application running in production, serving end users, and we're going to help Hero on their journey. Our job is to help Hero navigate hundreds of CNCF projects, choose which ones to use, integrate them with one another so Hero can live their dream. My name's Whitney. I'm with Viktor. Viktor and I together host a streaming show called You Choose. That's on Viktor's DevOps Toolkit YouTube channel. So you can get to the show there. So each episode represents a system design choice, and then we gather all the relevant CNCF technology that can do that thing, whatever it is. We invite a maintainer or a super user on from each of those technologies, and then we give each person only 5 minutes to tell us what their technology does, because we just want a quick overview. Then we ask the community to vote on what they want to see demoed. So whichever one wins the vote, we demo in our show, in our ongoing demo. But we're going to do that here. Oh, this is what y'all have chosen so far. I have to be able to look at the screen to be able to do this. Are you ready? So y'all, the community, you've chosen build packs for container image building, Harbor for image signing, for registry, Carvel for app configuration, Cert Manager for certificates, Crossplane to define a database as an API and then manage that database inside of Kubernetes, Schema Hero to add schema declaratively to that database, DevSpace for Kubernetes development, Argo CD for GitOps, Contour for Ingress, KubeArmor for runtime security, External Secrets Operator for to manage Kubernetes secrets, Cilium for pod-to-pod communication, Kubescape for Kubernetes scanning, Notary Project for container image signing, Cephy Spire for workload identity management, Keycloak for authentication, OpenFGA for authorization, Headlamp for Kubernetes UI, Theranos and Prometheus for metrics and scaling those metrics, Jaeger and OpenTelemetry for tracing and scaling tracing, Istio for service mesh, and OpenCost for cost management. This is too much, y'all. How are we doing this? This is a lot. So this is definitely too much. Maybe as platform engineers we could do it, but definitely too much to ask for our application developers and our application teams. So that's where a platform comes in. A platform is going to help. It's an integrated collection of capabilities that we can offer to developers that are organization specific. We can offer them to developers in our organization so that they can get what they need in a self-service way without having to understand all that complexity. So we have 3 groups of people that help with platforms. The first are the experts. The experts know a lot about one thing. So they're database experts, messaging experts, Kubernetes experts, and then we have our developers or our users. They're not always developers. I'm oversimplifying a little bit. And our developers need to get stuff from the experts. So in the past, our developers have either maybe tried to do it themselves and toiling on stuff that isn't their value stream, or they might put in a ticket to get something from the experts and then wait on what they're getting. So that's where the platform comes in. The platform and platform engineers are helping the developers get what they need from the experts in a self-service way. This is a little bit of an oversimplification, but it's a nice mental model. So an example would be our developers saying, hey, we need a database. And the platform with no human involvement says, hey, here you go. Here's that database for you. And it already has company security. It already has compliance. You don't have to worry about it. And they're happy about that. So now, with the 25 minutes left in this talk, we are going to build a platform live here for you, and you're going to choose what technologies that we use to do it. So we're going to go through 4 system design choices. We're going to choose a technology for API and state management. We're going to choose a technology that adds cluster level policy to our platform. We're going to choose one that executes one-time tasks. And then finally, we're going to choose a graphical user interface for our platform. So join with this link, and later we're going to have you vote. And then we'll make a platform together, and everything will be perfect in every way. So let's talk about APIs and state management. We're going to talk about Crossplane and Kubevela. But before we do that, why do we even need APIs and state management as part of our cluster? when I say API, I want to be a little bit more specific and say we want to build our capabilities with Kubernetes APIs. That doesn't mean our capabilities have to run on Kubernetes. What does mean we're going to use Kubernetes to manage the capabilities. And we're going to do that for 3 reasons. The first is we want to use that Kubernetes synchronization loop so we can define the desired state of something and then trust Kubernetes to keep our desired state in sync with our actual state. The second reason we're going to is because Kubernetes has a rich ecosystem of tools, and now we can use those tools to help us manage our capabilities. The third reason is everyone's doing it, so we should do it too. Which maybe in life in general isn't a good philosophy, but here in software it is a good philosophy, because when there's a community behind something, that means that thing has staying power and you're not building on something that will go obsolete. So let's say our application team wants to build a Kubernetes cluster. So right now we don't have an API deployed yet. As platform engineers, the first thing we're going to do is talk to an infrastructure expert who's forgotten more about making clusters than we have ever known. So we're going to work with her. We're going to define our API, our capability behind an API, and then we're going to install that into our Kubernetes management cluster. So, and we're going to do that with a tool like Crossplane or Cluster API, and put that inside of our cluster. So now our developers, they can ask for the development cluster that they want. How about one that's running outside of the cluster in Google Cloud? And then that gets applied to the cluster, and a tool like Crossplane or Cluster API picks it up and then gets it running, and now our developers have what they need. All right, so why then? I forget what I was going to ask right there, but that's okay. Oh, why do we want it behind APIs at all? Like, why don't we just build this into our backstage? Or why don't we just add this to our IDE? Why do we need this as an API? If we have it as an API, then we can offer it to our developers behind any of those interfaces. So a great example of this would be hyperscalers. So if you have Google, for example, you can access your Google through G-Cloud CLI. You could do it through the Google Web Console. You could do it through Terraform modules. But in the end, that's always going to call the Google API, and that's how you're getting your stuff. So if you have your tools built on APIs, you can then bring it to where your developer needs it in their workflow. Another reason to put it behind APIs is because they can be building blocks. So we have a building block for a Kubernetes cluster, one for a database, one that deploys our application, and then we can put those all together and offer one API that has all of the cluster already running, the application already deployed in it, and it's already connected to the database, all integrated behind one. So let's talk about the technologies. First up, we have Crossplane. Crossplane is a technology that lets you take any API on the planet and pull it into Kubernetes and manage it as a Kubernetes API. So this is great. That means all the benefits we just talked about apply to Crossplane. Crossplane also offers a way to simplify the interface. So we have all that complexity that Crossplane encapsulates, but then what we expose to the users is very simple, just a few fields and a YAML for them to to be able to manipulate only what matters to them. Crossplane is very powerful, and because it's very powerful, it's very complex. Next up, we have Kubevela. Kubevela is a way to deploy applications with Kubernetes APIs. So it's similar to Crossplane, but it's scoped only for you to deploy your own applications. So you can define and deploy applications behind an API that they offer it's called an application in Kubernetes. And you can use you can use components and traits to be able to define, like a component would be a web server, or there's a component that's an ingress, and then each of those have traits you can define. So there are lots of complexity abstractions for you to be able to define exactly how your application should run. And then there's a lot of community support. And then just like with Crossplane, there's a simplified abstraction called a workload that your developers can use to be able to run their workload without having to worry about any of the complexity of how it's deployed. So which one would you like to see demoed today? Please vote.
Be fast, we don't have enough time.
It's okay. The room gets so quiet. We need
5.
This is
4, 3, Kubella folks, go faster. 2, 1. I'm sorry, it's going to be cross-plane. Actually, I'm not sorry, it's awesome. Okay, so let's do cross-plane, right? Let me show you very quickly how that will work. First, because we don't have much time, I will set it up through a script. Normally, I would like to show you what's happening behind the scenes, but for now, script should do. And I'm going to go to the directory of my application. Here is my application, right? It's a Go application, does something, whatever it's doing, doesn't matter really. What does matter is that I already applied the crossplane beta trace, namespace, production, SQL claim, silly demo, DB, there we go. Come on.
Oh no.
The demos almost always fail, but not at the very beginning. Okay, cool. So I will show you how I did what I did, but for now what matters is that all the components, everything required for the database is being created right now, right? It's in a process of being created. It will finish hopefully soon. And what I want to show you now, let's say that the database will soon be running. How do we define an application through a platform, right? An application for a developer can be something like this. Hey, I have a custom API in Kubernetes called UpClaim. You define it, and the magic will happen behind it. In this case, I'm saying I want the backend database running in the same cluster local. This is the image. This is the tag, the port, the host, the ingress class name. I want to connect to the database through that secret, and I want to use this repository, CNCF demo app, right? That's the user-facing, developer-facing interface. Behind the scenes, a bunch of things will happen, and if it works, we'll see what that is. And now, since I don't have time, imagine that I already, before the demo, I already applied that manifest. And I can show you the result of applying that manifest, which is in namespace, production, space, production, get all, and ingresses. And come on, I'll blame Wi-Fi. Wi-Fi is called, OK, there we go. That simple YAML created a service and the deployment. Deployment created replica set created pod, and it created ingress, right? So it's kind of awesome. Now, the problem with this so far is that we have now interface how to deploy application to production with a very, very simple interface. But the application is not working, right? There is no image. We haven't built one yet. We'll get to that in a second. And until we get to that, kubectl namespace production, because there are a couple of things missing. I will delete what we did. File name is apps silly demo. There we go. I'm going to delete the application because we need still to fix a couple of more things. Add, commit, something, and push. No, sorry. Push. You haven't seen this, not recorded, right? There we go. Now we can go to the next choice. We figured out how to deploy how to create database in AWS, Google Cloud, Azure. We figured out how to manage applications. Now we need to figure out other things.
So now we're going to talk about cluster level policies. We're specifically going to talk about validating admission policy and Kyverno. So why do we need policy at all? Let's say, in our example from before, let's say our application team asks for a 300 node cluster. Now, this was probably a typo, but we want to make sure it doesn't happen. So we can use policy to do this. So the request is going to go to the Kubernetes API server. Now, the Kubernetes API server already has validating admission policy. So you could have put a policy at this level that says don't allow a cluster in that's more than 5 nodes. And if that's the case, it's gonna kick it back and say we can't make this. Now, you could have Kyverno running in the cluster. If that's happening, Kyverno is has an admission controller webhook as part of the Kubernetes API server. So it's basically configuration in the Kubernetes API server that says if a request that comes into the cluster that falls under the jurisdiction of this rule, don't just make the thing, instead send it to Kyverno. And Kyverno has the rules engine running, and Kyverno will say yes or no, it's not allowed to be created, and that gets kicked back to the user, hopefully with a helpful error message about how to fix it for later. So you want to use policy to do all kinds of things, though. You might use it to reduce resource bloat. You might use it to make sure they use the right dependencies to make sure that they're pulling from an internal registry and not a bad registry. And that's really the tip of the iceberg. So validating and mission policy, as I mentioned, is already in Kubernetes. There will be a mutating mission policy soon, I believe, too. With validating a mission policy, you use CEL to write your policy, which stands for Common Expression Language, which is pretty lightweight and easy to use, and it's also Turing incomplete, which makes it more safe. Then we have Kyverno. Kyverno, honestly, I'm going to have an opinion here. Validating a mission policy, if you could use it for your use case, you should use it for your use case, and then go to Kyverno when you're ready. Partly because Kyverno, you can write your policy in CEL, so it moves right over to Kyverno. There's also Kyverno JSON query language that's meant to look and feel like YAML. Kyverno can do other things. It definitely does mutation policy. It does resource generation. You can make policy reports. You can add policy early in your CI/CD pipeline, so if it's going to fail, you find out sooner. There's a lot of bells and whistles with Kyverno. It's a pretty mature technology. So with that, what would you like to vote for and see Viktor demo?
Okay. 5, 4, 3, 2, 1. Okay, it's going to be Kyverno. We don't have enough time for you to make up your mind, so let's just do it. I'm going to set it up again through a script, mostly because we don't have enough time. And let me show you one policy. There we go. Cut policies, Kyverno, IDP. What did we choose? We chose crossplane. Cool. Here we go. Right. This is a relatively simple policy. It's a cluster level policy, means that it can be applied anywhere in a cluster, and it will look, if somebody creates upclaim, that's the application we defined earlier, right? So if somebody tries to push upclaim to the GitHub API and try to create or update that resource, it will check, is scaling defined? If it is there enable defined? If it is that enabled through field set to true, right? So basically, is scaling enabled for application? And the other one is the minimum number of replicas set to be greater than 1, right? So the rule with this policy is that applications needs to be set to be scalable and to have multiple replicas, more than one replica. Really, very simple rule. And let's apply our application again. I have it here somewhere, probably, maybe not, who knows. kubectl namespace production apply. File name is CNCF demo app silly demo, right? That's this apps. There we go, silly demo. This is the same YAML that we saw earlier, right? That I showed you for the application. We tried to apply it and create it. This was not the expected outcome of the policies. Did they even apply? Kube control, apply, file name. It's fine. If the demo doesn't fail at the very beginning, but somewhere in the middle, it's fine. It's going to be okay. It's going to be great. Maybe. Cool. Let's see now. No, not delete. Apply. Okay, cool. Praise the Lord. Essentially, what this thing told me is that, Viktor, you're an idiot. How did you dare not to define enabled field set to true to enable scaling? So Viktor is going to improve that. What is it? Parameter scaling min. Cool. I'm going to add scaling min. Let's make it 3, right? And now if I try to apply my application, did I make a typo? Is somebody saying something?
No.
And enabled needs to be set to true. There we go. Cool. It caught both of the use cases, and now my application is up and running. I mean, it's still not up and running because the same problem as before. Get all. We still did not build the image, but now at least we have a safety net that we cannot do whatever we want. We can do only whatever is based on the rules that somebody defined. So let me go there again very quickly. Add stuff to Git, commit, push. This time works. I don't need to use my shortcuts. Cool. Let's talk about the next one. We know how to enable policies. Cool.
All right, let's finally get that image deployed made. Let's talk about one-time tasks. So we're going to talk about Argo workflows versus Tekton. So one big thing that our developers and our app teams need to do is that they need to get their code built into a container image. So they need their code to be tested. They need that to be built into a container image. They need that image to be pushed to a registry. They need the configuration to be updated with the new registry. They need to test that new configuration, and they need to go into an application configuration repository where Argo CD can pick it up. So this is probably familiar. This is a pipeline, and it's something that's a very important part of the developer experience and something that we should support as platform engineers. And it doesn't fall under state management because this happens only one time. So how are we going to support platform engineers with building CI/CD pipelines and deploying CI/CD pipelines? So for one thing, we could give them a template. They need a pipeline. As a platform engineer, we could say, here's a template. This follows all of our company best practices, and you can extend it for your use case. It already has security and compliance and all of that. You can take it and you can customize it, and you can run your pipeline wherever you're already running your pipeline, because surely you're doing that by now already. As a platform, we can go one step further, and we can install and maintain the tool, and we can provide compute to run that platform, to run that pipeline, CI/CD pipeline. So if in that case, in our management cluster, we'd run a tool like Tekton or Argo workflows, and then we'd apply the pipeline definition to the cluster. Then nothing happens because a pipeline needs to be triggered. And we're not watching state here. So it's usually triggered by the developers pushing code to get, and then that's going to trigger the pipeline, and then it's going to go through our entire series of steps. And then when it's done, it'll stop running. And we can support that as platform engineers. So which technology do we want to choose today to demo? The first one is Tekton. Tekton is designed for exactly this use case, where one step leads to one other step, leads to one other step, leads to one other step. It can do threading. It can do could lead to multiple steps. It can do conditional logic, but it's not designed for those use cases. It's designed for something that's to be simple. And it's great, and it's easy to use. I'm a fan. Argo Workflows is designed for an AI ML use case, where one task leads to several tasks, and each of those leads to several tasks, where it looks more like a tree than a pipeline. In fact, it's called a workflow. It's not called a pipeline in this case. Argo Workflow it's designed to have more complex logic too that's available to you, and because it's more powerful, it's also more complex, which you see over and over again in software. So more powerful, more complex, and which one would you like to see demoed today?
Oh, we have 5 minutes. 5, 4, 3, 2, 1.
Oh, it's close this time.
Argo workflow. There we go. Was it Argo workflow? Yeah, it's still Argo workflows. Okay, cool. Let me set up first. This is unrelated, but I realized that I forgot to set up Argo CD while she was talking, so we're going to do that quickly, even though we're not talking about it. You know what is Argo CD, right? I don't need to tell you. Come on. Still 5 minutes. It's going to happen soon. It's coming. Okay, cool. Let's set up Argo workflows manuscript. Where do I have workflows? Workflows, there we go. Argo workflows. This is scripted. We'll set it up. Nothing really special. There is not much going on there. And let's take a look at one workflow. Workflow, Argo, there we go. This is a pipeline, essentially. Basically, what I'm doing, and I don't have much time to explain, I'm doing everything. Check out the code, generate the tag for the image, build the image using Kaniko, which, Google, shame on you, not maintained anymore. Run some unit tests, push it to Git so that Argo CD can synchronize it, and so on and so forth, right? A pipeline. Now, let me submit it. Argo submit, is this correct? Looks correct, probably. So I'm going to run the pipeline, and it will do all those things that we were supposed to do. And the most important of the things that it will do, it will build the image that prevented the application of working in the first place. And then when the image is running, it might work. No, it's not 5 minutes, it's 3 minutes left. Anyways, while this is running, who knows if it works, let's go through the rest of the slides. One more choice. Whitney, be extremely fast.
Fast.
I can do it for you if you want.
Okay, backstage port. The problem is this needs to scale across lots of teams and lots of capabilities, and when it does, it gets really confusing. So how do we let developers know what's available to them? How do we let the platform engineers know what's already deployed? We do that. GUI helps with that, but it is optional. You can do a platform without a GUI. So developers can see what's available. They can see education about what's available. They can see what they've already provisioned, and they can actually take action through the interface. And platform team can also see everything that's made across the cluster. This is also read-only from Kubernetes API server, so even though it's handy-dandy to have in a GUI, you can do it with kubectl. So with the CLI. So we need to manage this, so let's look at the tools. The tools are Backstage. This is like the second most contributed to project in the entire CNCF behind Kubernetes itself. Very, very large community support. And it can be hard to use when you're making your own plugins for your own tools because you have to know TypeScript. But mostly for any third-party plugin, third-party tool, there's a wildly huge ecosystem of plugins.
If you don't know TypeScript, Sonnet, Anthropic knows it, no worries.
There you go. That piece has been solved. Port is a commercial offering, but it offers a low-code, no-code approach to be able to make a GUI. And so what would you like to choose?
2 minutes. Go. 5, 4, 3, 2, 1. Backstage. Cool. Now, this is still building. Blame Argo workflows. It's not my fault that it's slow as hell. So imagine that it built and the application is running now. Use your imagination. We don't have time. Now, if it did work, what you would see here in Backstage, you would see your application and the database, and let's say actually the database should be already there, right? The application is already there. There we go, right? And you can see the information about it, graph, because everybody likes boxes and arrows and what's or not. There we go, right? And you can see what that specific component, in this case application, consists of. Or more importantly, and this is important because it's API, I did not hard code anything in Backstage. I never told Backstage there is a database, Backstage went to my cluster, digested all the schemas from my cluster, and auto-generated this. And this is basically, oh, okay, I discovered that there is something called up claim, there is something called GitHub claim, there is something called SQL claim. What do you want? Oh, I want second database because I want to waste my money. And you say second DB, you fill in the fields, whatever the fields are, blah, 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 next, 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 next. You click push, you click save, and it doesn't do anything in a cluster because that would be stupid. It pushes things to Git, and then Argo CD synchronizes it because nothing should have direct write access to the cluster. And then we live happily ever after. We have 1 minute.
Give me the slide.
Yes, you want slides? There we go. Slides, slides, slides.
Thank you so much, y'all. We built a platform in 25 minutes. That was awesome.
Almost.
There are YouTube stickers here up on the stage, so come help yourself, and we'll have them with us, so say hi. And that's a YouTube for you choose. Thank you, thank you.
Thank you.